Alright, this is the notes for section 8.7, special right triangles. If you haven't done so already, make sure that you read this section first before continuing on with this video. In 8.6 we looked at the idea of Pythagorean's theorem and how it relates to right triangles. Here in this section what we want to do is we want to look at two special right triangles, and what makes them special is the ratio between the angles of those right triangles, the extended ratio. By extended ratio we just mean that there's more than two parts. So if I look at this first one, it's an isosceles right triangle. The angle measures are 45, 45, 90. Therefore the ratio between their sides is 1 part to 1 part to 2 parts. So you'll notice that each of these smaller angles is half of the bigger angle. Okay. Well, what we want to be able to do in these special right triangles is be able to determine, if I know that that's the ratio between their angles, what's the ratio between their sides. Okay. And we have our statement here, and in the book it kind of goes through as to why this is. But in an isosceles right triangle, if the leg of the isosceles right triangle is x, then the hypotenuse is x times the square root of 2. Okay? So this triangle here, where I have these labels, that's the important part. So I know that if no matter what the value of the leg length is, so if we're going to call it x, well, it's isosceles, so I know both of them have to be x. Well, if that's the case, then the hypotenuse will always be whatever that number is times the square root of 2. So if this number is 3, this right here would be 3 square root of 2. If this is 5, it's 5 square root of 2, etc. So let's take a look at example 1 then and see if we can apply this this idea for isosceles right triangles. In example 1 it says find the missing side lengths in the given isosceles right triangle. So we know these are isosceles right triangles. Therefore, if I look at this first one, I know that these two sides are equal in length. Okay? And in terms of its relationship, if we call these x, I know this side over here has got to be x times the square root of 2. Well, I also know that that side is 13, so what that means is I can say 13 is equal to x times the square root of 2. Well, if this is a true statement, I can solve it for x to find these sides. So if I take 13 equals x times the square root of 2, to solve that I would divide by the square root of 2 on both sides. Therefore x is equal to 13 over the square root of 2. Okay? Now, generally we're going to simplify that, and the general rule of thumb is we never leave a square root on the bottom. So what we can do is we can multiply top and bottom by the square root of 2. If I do that, I get 13 times the square root of 2 over 2. Now, if you do this on your calculator, 13 divided by the square root of 2, it's going to give you this value if you look for an exact value. So that means that the value of x is 13 times the square root of 2 over 2. In the second one, we're given one of the sides that is equal to, of the ones that are equal to each other. So if this one's 5.3, this side right here has to be 5.3. And then the side opposite, we know it's a x square root of 2. So if 5.3 is x, then this third side, or my hypotenuse, has to be 5.3 times the square root of 2. So the answer there is 5.3 times the square root of 2. So let's take a look at example 2 here. It says to find the area of figure ABCD. If you'll notice that we have some measurements on this, I'm going to be able to say that this is a trapezoid. Let's look at how that works. If this angle is 45 degrees here and this is 90 here, then this angle right here would have to be 45 degrees, because together that triangle has to equal 180. So I know this triangle ADC is a 45, 45, 90. And then if I look at this other triangle, if this angle is 45, then this angle up here has to be 45, and therefore that is a 45, 45, 90. And you'll notice that that makes this angle right here a right angle. So if these two angles are both right angles, that tells me that these sides are parallel to each other. So what I'm going to be able to do is I'm going to be able to find the area of that trapezoid. Okay? Well, let's use the measurements on this 45, 45, 90 to find all the lengths here. So if this is 8 feet, then I know these two have to be the same. Therefore, this would have to be 8 feet. Now, I don't need this length except for the fact that I'm going to use it to help me find these other ones. So if this is 8 feet and this is 8 feet, I know this is 8 times the square root of 2. Well, I know that that's one leg of this isosceles triangle. Therefore, this is 8 times the square root of 2. And this, remember, that's my x value for this triangle. So that means for this triangle right here, x is equal to 8 times the square root of 2. And I know the hypotenuse has to be x times the square root of 2. So it's going to be 8 square root of 2 times the square root of 2. Well, if I multiply that out, 8 times the square root of 2 times the square root of 2, the square root of 2 times the square root of 2 is 2. Therefore, that's the same as 8 times 2, or 16. So this side right here is 16. This side here is 8. And I know the height of my trapezoid is 8 as well. Those are the three measurements I'm going to use to find the area. Therefore, the area of that trapezoid is equal to 1/2 B1 plus B2 times h. So the area is equal to 1/2 times 8 plus 16 times 8. Well, 8 plus 16 is 24. So the area is equal to 1/2 times 24 times 8, which is equal to 1/2 times 24, or 12 times 8, which is equal to 96 square units. Alright, the second special right triangle that we're going to look at is a 30, 60, 90 triangle. And by 30, 60, 90, meaning that the angles of that triangle are 30 degrees, 60 degrees, and 90 degrees. And that extended ratio here, instead of 1 to 1 to 2, is 1 to 2 to 3. So for every one part in the smallest angle, there's 3 parts in the biggest angle and 2 parts in the middle angle. Okay? In this type of triangle, what happens is the shorter leg is x. The longer leg is x times the square root of 3. And the hypotenuse is 2x. So on this triangle, I have that labeled. Here's the smallest side, which is opposite the smallest angle, x. Here's the longer side, opposite the longer leg, I should say, opposite the bigger of these two angles. And then finally, the hypotenuse is the longest side, which is 2x. But they're all interrelated with that x. So if I know any one side for this 30, 60, 90 degree triangle, I can find the other two. So let's take a look at example 3 here. It says find the area of the triangle below. So in order for me to find the area, I know my area formula is A equals 1/2 the base times the height. For a right triangle, the base and the height are the two legs. So I need to figure out what this value for B is here. Well, if this is 8, that's my shorter side. That's the x. So that means 8 is equal to x. Therefore, the longer side, because the longer side is x times the square root of 3, would have to be 8 times the square root of 3. Now, I can find this other side over here. I know this is going to be 2 times 8. or 16. But I don't really need to know that in order to find the area. So now to find the area of this triangle, I'm going to take 1/2 times 8 times 8 times the square root of 3. Okay. Well, if I do that, the area is equal to 1/2 of 8 is 4. 4 times 8 is 32. So it'd be 32 times the square root of 3. That would be the exact area for it. And then we would write that in terms of units squared because we're talking about area. Now we could get a decimal approximation to that as well, but this is a fine answer for this particular problem. Okay, so the next term that I'd like to look at is the term apothem. And the apothem is the perpendicular segment from the center to any side of a regular anagon. So when I'm looking at the apothem, it's the distance from the center of this regular polygon to the side. It's got to be measured perpendicular to that side. And we could do that to any side as long as it's perpendicular to that side. And we know that that distance has to be the same within that regular polygon. Okay? Now, if we know that distance, and we know and are able to find the perimeter of the regular polygon, we can find the area of the regular polygon. Okay? And what it says is that the area of a regular polygon is always going to be half the apothem times the perimeter. Okay? So let's take a look now at example number 4 here. It says find the area of the regular hexagon with a side length of 8. Okay, so this is a somewhat difficult problem because they didn't give us the apothem and we have to find it. Well, to do that, first of all, remember if I'm going to find the area of this thing, I want to take 1/2 times the apothem times the perimeter. So the two numbers that I need to figure out is what is the apothem and what is the perimeter. Well, the perimeter is a pretty easy one to find. I know each side is 8 here. Well, if each side is 8 and there's 6 sides, it's going to be just 8 times 6, or 48 units for the perimeter. Okay? So now we have to find that apothem. To do that, what we're going to do is we're going to look at these triangles. So if I look at this triangle, going to each of these vertex points, I know because there are 6 of them that this angle here, that big angle, is 60 degrees. Okay? Well, if that's the case, the apothem has to be the bisector of that. Therefore, I'm going to erase this just so I can kind of write on it here again. Therefore, if I look at the distance from this distance right here, this angle would have to be 30 degrees because it has to be half of the 60 degrees. So if that's 30 degrees, I've got a 30, 60, 90 because this is 90, therefore this is 60. Well, I know that this whole length here is 8, therefore this distance here has to be 4, half of it. And if that's 4, then the apothem, according to the 30, 60, 90, has to be 4 times the square root of 3. So I know my apothem is 4 times the square root of 3. So now I have the two distances that I need to find the area. Therefore, the area is equal to 1/2 times 4 square root of 3 times the perimeter, which is 48. And what we're going to do there is we're going to get a approximate answer. So if I do, well, let's get you know what? Let's get an exact answer first, and then we'll get the approximate from there. So the exact answer, I'm just going to take 1/2 times 4 times 48. If I multiply those together, 1/2 times 4 is 2. 2 times 48 is 96. So I can write that as 96 times the square root of 3. And then I can go ahead and put that in my calculator to get an approximation to that. That would be equal to approximately 166.28, and that's square units.